Yeah, gone, man. You missed it.
Okay, enough about my jokes. So now, Ricardo, please go ahead and start your presentation.
Can you see my screen? Okay.
Yes.
Well, first of all, thank you all for being here. And my name is Jesus Ricardo. I graduated also from Chihuahua University. I'm an old student there, and I'm really happy to still see really old friends. And I'm gonna talk about today my research project, and is in the addition of the New Mexican chilled byproduct into a trim feed. But first of all, I'm gonna start talking for a brief description of the problem. And we are facing one big problem as humans. And every year the population is still growing. So we need to fulfill a demand of protein. And in the last years, the fish protein become more popular because it's a premium source of protein. And in some countries, it's cheaper than producing meat. And as you can see in this graph, we have a production of 60 million tons of fish for human consumption. But that is a big problem at this moment, because we need more proteins every day. And for that reason, another industries are taking more weight in this process. And one of them is aquaculture, which is producing fish species and lowering the cost of production and having more yield. And the thing is that each year is more difficult to still obtaining protein for the oceans because we are over fishing those fish banks. So you can see that the amount of aquaculture already passed the amount of fish that the human consumes. And this have a big problem there, because most of the species that are cultured in aquaculture obtain the feed from the fish. So we need to fulfill two sources of protein, one for humans and one for the food that we eat. And for that reason, the aquaculture has like a higher impact in the last years. And most of the species that are mainly produced are the carp, the tilapia, and the shrimp. And the shrimp is becoming more popular in the last years because have a huge potential to still grow in it. And for example, in 2017, the aquaculture production of shrimp represented an earnings in $26 billion, which is a huge industry. And I mentioned that this can still obtaining more yield of production because most of the earnings for the shrimp production in aquaculture are affected by the feed or the source that the farmers use it to feed the shrimps. And that's because more than 50 or 60% of the feed is mainly composed of fish, the fish meal. And I mentioned that before, that every day is more difficult to obtain fish. So for that reason, the price of the fish meal is increasing in the last years. So you can see here that the price for a metric ton of fish meal is more than $1,000. And for that reason, this represents more than 50% of the earnings on the production. So some investigation or research are concerned about changing that source of protein to increase the yield of production of the shrimp and making more money. And I think everyone wants to earn more money. And for that reason, another sources of protein are becoming more popular. And the thing is that, for example, and one area that is becoming more popular is the plant-based proteins. And one of those is the soybean meal, which is around $300. And another one that is becoming like more important in the last years is the glandless cottonseed meal, because it's rich in protein. So here you can see in this table that is being reported about 40 or 50% of protein for this product. And something that is really important to mention here is that the glandless cottonseed meal, this is a byproduct of the cotton industry. So they are taking advantage of one of the byproducts of the industry, and the textile industry is huge. So it's a huge amount of glandless cottonseed meal that can be useful to create added value products. In this case, they are trying to introduce in feeds for aquaculture. And I'm gonna talk about more for the green chili, because maybe you are thinking why he is working with chili and also shrimp and how he is gonna link those topics. And the thing is that New Mexico is really famous for the production of chili. For example, New Mexico produced around 7,000 tons of chili in 2018. And New Mexico is the first producer of green chili in the United States. And we were talking about that each time that you process something, you are going to generate waste. And it's really important to take advantage for those waste in order to become a more ecological, friendly economy. And in this case, most of the chili that New Mexico produced in 2018, most of that part went to the production of another processed foods like salsas or canned foods. And that market represented more than $40 million. And on the other hand, only $8 million represented for the fresh or the chili that we consume in the market. And something that is really interesting is the half of that production is used for one company, and is producing around 3,000 tons of chili waste, which is huge. And they are using it to selling to the farmers to forage. But the thing is that they need to pay for the transport of that waste. But they are not selling it, only you need to go and pick it up. And that's part of this research project to identify and characterize this bio waste or this waste, and then added a value. And most likely, some of the compounds that are present in the chili can be useful or good for the shrimp. For example, the chili waste can be rich in carotenoids, and some of them can be the lutein, the zeaxanthin, and the beta carotene. Those can be useful for the shrimp to basic functions, and also can help to obtain a better appearance to the shrimp. And another compounds that can be present in the chili bio waste can be the capsaicinoids. And all of those compounds that I mentioned have a good antioxidant capacity and can be helpful for the shrimp. And also it's been reported that the chili waste can contain good amount of dietary fiber. And some studies reported that feeds with 50% of crude fiber can help to reduce the time passage of the feed on the shrimp, so they can absorb a little bit better the nutrients on the product. So this is the main objective of this project, that is to evaluate the effect of extrusion variables and the concentration of chili waste on the physical and nutritional properties of the extruded feed for shrimp. And to achieve this, we need to characterize the chili byproduct to create an extruded feed with different concentration of GCSM, because it's going to be the main protein source, but should be complemented to be a whole feed for the shrimp, and analyze the physicochemical properties of the different shrimp feed extrudates. And finally, study the effect of the chili byproduct feeds on in vitro protein digestibility. This in order to obtain an optimum feed before going to the in vivo assays. So first of all, we need to know the methods that we are going to use. And the first step is to dry the sample. And two commercial methods that are available are the freeze dryer and also the convection dryer. So we need to evaluate which one is better. And we need to take in consideration the prices of drying these waste in order to be able to scale up this process. Then we need to mill or grind the chili. And finally, we need to do all the tests that are a lot to understand more about this feed, and also in order to standardize more the raw product of this research project. And so we need to understand the crude protein, the minerals, the crude fat, the ash, the total phenolic compounds, the antioxidant capacity, the total carotenoids, and the color of the powder. And something that I didn't mention is that the chili seeds are rich in linoleic acid, which is one of the fatty acids that the shrimp can use, and also some of those minerals, for example, calcium, phosphorus, are good for them. After characterizing this bio-waste, we are going to try to introduce the product using a surface response surface methodology, just to see the effect of the variables of the extrusion process on those feeds, because it's reported that temperature and screw speed can change some of the physical properties that are for the feeds, that the shrimp are going to be attracted to them. This is more likely to make a feed that the shrimps can eat, and that is easily to recover. And also here, the chili waste make something really important, because it's a high fiber product, and it's going to change the texture of the product. So if we add too much, maybe the shrimp is not going to like it. That's why we need to find an optimal concentration of chili waste that we can add, and the shrimp will still like it. And some of the variables that I mentioned before were the protein digestibility. So we need to run that test before in vivo, so we can understand how is going to be the in vivo test. And at the moment, we're still in the preliminary phase of this research project, and we're obtaining the composition of the chili waste. And here we can see that it's mainly total fiber, but still we still having crude protein and a little bit of crude fats. Then I analyze the drying methods with color and total phenolic compounds. I made it with 4-inch calcium method. And we can see here that in the freeze drying, the total phenolic compounds are lower than the oven drying. At this moment, this looks like oven drying can be better because it's cheaper, but we need to analyze, for example, reducing sugars in order to know if it's related to this result. But we still need to analyze the antioxidant capacity and the total carotenoids and identify which of those are the mainly present in the waste. And this is more for the things to do. So I still need to characterize the carotenoids, the capsaicinoids, the fatty acids, the amino acids, the antioxidant capacity in the chili waste, and then I'm gonna work in the extrude. And I think it's time. So this is part of my research. I am on the preliminary steps. So if you have suggestions, feel free to contact me. And I hope you enjoy it a little bit. And thank you for your attention.
Thank you, Ricardo, for your presentation. Is there any questions for Ricardo related to his research?
Yes, I have a quick question, Ricardo. That was actually
Yes.
a good presentation. I really like it. How much longer do you think it's going to take for the research, or how much, I guess I don't know exactly how long it takes to do something like what you're doing, but you know how you said that there's still a process that you guys are still pending. How much longer do you think, or you estimate that that's going to take?
Well, I'm thinking that if I got accessibility to the equipments that I need, this can be done maybe in 5 months, and maybe that's too long. The thing is that most of the things that we are waiting is for the this part, the chili waste. But for that one, I'm seeing like a month or two to make the results. And then I need to analyze those results in order to know if I need to repeat them or make more, and to adjust the time frame. But after that, the extrusion can take like maybe 1 month, and analyzing the physical properties also 1 month. So this, I would like to finish this project in around 6 months of hard working.
Oh, I see. Thank you. Yeah. So basically, if you have the equipment or the right equipment with you, or at the labs or wherever you're working at, the process will be done faster, or does it actually take that long even if you have the equipment with you?
Well, that depends if the results that I got were what I'm thinking. But even if I didn't get those results, I can still making a discussion about what I got those results. So I think I need to finish this in 6 months.
Awesome. Okay. Thank you, Ricardo.
We have time for one more question.
Good job, Ricardo. This is Miai.
Hey.
Hi, I just wanted to know, how long have you been working on your research up until this point with what you presented to us today?
To be honest, maybe 3 months, because I was working in a side project that involves the shrimp. So at that moment, we already finished, but the shrimps that the leftovers of the shrimps that we don't need in that experiment, we left them to make the protein in vitro digestibility. So I need to still take care of them. And so yeah, maybe 6 months since that.
Okay, thank you.
So essentially the whole pandemic.
Yeah, and the thing was that we obtained some chili waste before the lockdown, and then we need to wait a little bit for the next batch, and that was the hardest part because every time I wanted to do something.
Don't worry, Ricardo. I'm pretty sure every single one has a similar story. That's the only reasons. Okay, I think it's time to move on to the next speaker. Erica,